18. We're going to jump down to the workbook question 10. All right, so in the diagram, segment AE is tangent to the circle at point A, and segment DE is secant to the circle at point C and D. What is the length of DE? Okay, well, I'm thinking to myself, what do I have? We have a tangent segment and we have a secant segment. So I'm thinking, okay, there was a theorem for that, and it said that the tangent segment squared was equal to the product of the whole secant line, so DE, being multiplied by the exterior part, so CE. Okay, so then I'm going to use substitution. We know from A to E is x plus 5. So we have x plus 5 being squared, and that's going to equal, well, DE. That's the total distance. So our total distance right here is going to be 16 plus, because that was from D to C, plus x minus 1, because that was the rest of the distance from C to E to make that whole distance. And then we have CE, which is x minus 1. So we're going to multiply that by x minus 1. And now we're going to simplify. So one thing you can do is you can come over here and you can type in x plus 5 in parentheses, and then you use the caret and 2. And type in expanded form. So all right, that's not. Okay, I'm going to edit that out. All right. So we have x plus 5 squared equals 16 plus x minus 1 times x minus 1. So let's simplify on both sides. X plus 5 squared is x plus 5 times x plus 5. That's going to equal, well, inside this parentheses I have a 16 and a minus 1. So 16 minus 1 is going to give me a 15 plus x. That's going to, and then x minus 1 inside that parenthesis does not have any like terms, so it stays as x minus 1. So now we need to distribute. So we have x times x, which is x squared, x times 5, which is 5x, and then we're still in that same parentheses, we have 5 times x, which is 5x, and then we have 5 times 5, which is 25. So when you multiply a parenthesis, something that has two terms in it, you have to multiply both of those terms. So then we're looking at this again. We have two terms. So we have 15 times x, which is 15x. We have 15 times negative 1, which is negative 15. And then we still have this x. We have x times x, which is x squared. And then we have x times negative 1, which is negative x. All right, and now we're going to combine like terms. So we have a 5x and a 5x on the left-hand side. So we have x squared. 5x plus 5x is going to give us a 10x plus 25 equals, and on this side we have a negative x and a 15x. So 15x minus x is 14x. We have minus 15 and plus x squared. So now we want to collect all of our like terms on the same side. So I'm going to just start. This one has an x squared and this one has an x squared. So I'm going to combine those, and since I have to cross that equal sign, I have to subtract them, do the inverse operation. So since this one sign wasn't there, it's assumed to be positive. So positive x squared, the inverse operation, it would be subtract. So subtract x squared, subtract x squared. So x squared minus x squared is 0 plus 10x plus 25. That's going to equal 14x minus 15, and x squared minus x squared is 0. So then, so then we have 0 plus 10x plus 25. Well, 0 added to anything doesn't change its value, so we have 10x plus 25 is equal to 14x minus 15, and again, because we're adding 0, it does not change the value. So now we have an 10x over here and a 14x, so 10 sign is not negative, so it's assumed to be a positive. So we subtract 10x to both sides. So 10x minus 10x is 0 plus 25 is equal to 14x minus 10x is 4x minus 15. Alright, so 0 plus 25, 0 does not change that value. So we have 25 is equal to 4x minus 15, and I'm going to box myself off right here and start at the top. We have 25 is equal to 4x minus 15. So now I notice that I have an x and a constant, so I want to move all of my constants together. So since I have an x and a constant and only a constant on the left side, I'm going to move this 15 over to the left hand side. So since it's negative, I'm going to add 15. So add 15. 25 plus 15, 25 plus 10 would be 35, plus 5 more is going to give us 40. And that's going to equal 4x, and minus 15 plus 15 is 0. So then we have 40 is equal to 4x, because adding 0 to it does not change. So now we have 4 times x, and since it's multiplying, the inverse operation is division, so we're going to divide by 4. 40 divided by 4 is 10. That's going to equal 4 divided by 4 is 1x. Alright, so 1x, x equals 10. So now we have that x equals 10, and we're going to come back here. What is the length of DE? Okay, D to E was that whole distance. So we know this segment is 16, and this segment is 10, is x minus 1. So we now know the value of x is 10. So I'm just going to substitute it in. So DE is going to equal our total distance from D to C plus the distance of CE. So DE is going to equal, well, D to C was 16 plus CE is x minus 1, and we now know that x is 10, so I'm going to substitute 10 in as well. So we know that it's 16 plus 10 minus 1. So 16 plus 10 is 26, minus 1 is 25. So DE is equal to 25. And let's check that. Great job. Okay, now let's move on to question 9. Again, if you have questions, please fill out a help form and I'd be more than happy to help you out. Question 9. In the diagram, AE is tangent to circle at point A and DE is secant to the circle at points C and D. What is the value of X? Okay, so we have a similar setup. We have a tangent line there and a secant line. So again, we know that AE, the tangent segment squared, is going to equal the total line, so DE, times the partial CE. And so I'm going to see that. And so by substitution, we know that AE is equal to X. So we have X squared is going to equal DE is going to equal 5 plus, so DE is this short segment plus X minus 2. And then CE is just the outside segment, so X minus 2. All right, now we're going to simplify before we can solve. So we need to handle all of the parentheses. So X squared is just X squared. That equals, well, we have 5 plus X minus 2. 5 and negative 2 is a 3. Plus X, because that like term didn't go anywhere, times X minus 2. Well, we still have parentheses, and when we have two terms in a parentheses, we're going to distribute. So we have 3 times X. So first off, our left-hand side didn't change. That's going to equal 3 times X is 3X. 3 times negative 2 is going to be minus negative 6. And then we're going to do the same for our second term in the parentheses, the X. X times X is X squared. And X times negative 2 is negative 2X. Alright, and now we need to combine like terms. So we have X squared on our left-hand side is equal to, and I'm scanning this side, this one has a 3x and that's a minus 2x, so together 3x minus 2x is a 1x, minus 6, that didn't have a like term on its side, on the same side, and plus x squared. Okay, now since we've collected and simplified each side individually, now we're going to start moving across the equal sign. So we have a plus x squared and an x squared. So plus x squared, to move it over, I'm going to subtract x squared and I'm going to subtract x squared. And that's going to give us x squared, that is not a division bar. X squared minus x squared is 0. We still have our minus 6, and we still have 1x. That's going to equal x squared minus x squared is 0, so we have 0 equals x minus 6. Okay, so we have x minus 6. I want x on one side and all of my numbers on the other side, so I'm going to add 6. Add 6. So then we have 0 plus 6 is 6 equals x, and minus 6 plus 6 is 0. So then x plus 0 is x, and that equals 6. So our answer is x equals 6. Great job. Okay, now we're moving on to question 8. In the diagram, segment PO is tangent to the circle at point O, and segment PR is secant to the circle at points Q and R. The segments intersect outside of the circle at point P. James must prove that PO squared is equal to PQ times PR. Which postulates or theorems should James include in his plan for his proof? There is more than one correct answer choice. Select all the correct answer choices. So I'm going to jump back up to the section, and I'm going to look for that proof. So right now I'm looking at the proof that is similar to what they're asking James to prove. So now I'm looking through the reasons. We have one that is given, they restated it, and then through any 2 points there exists exactly one line. They use the inscribed angle theorem. They used if a tangent and a secant or chord intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. They're using that previous theorem. And then they're using substitution property, the definition of congruent angles, reflexive property of congruence, and angle-angle similarity postulate, definition of similar triangles, and the multiplication property. So now let's scan back and see if we can remember those. Alright, so there wasn't a base angle. They had an exterior angle, inscribed angle, and an angle-angle similarity postulate. So let's submit that for grading. Some of the answers selected are incorrect. Did they have inscribed angle theorem? Maybe I'm just remembering too many. Maybe it wasn't exterior angle. Anyways, I would go back and double check. Great job. So it wasn't the exterior angle. I was just remembering too many. So on your when it asks for which postulates, go back to the proof that they included in the class, in the lesson, and look through all of the reasons. And if you need to, write them all down and then come and compare them to the ones that are listed. I'm going to jump to question 6. So we have that in the diagram, AP is secant to the circle at points AB and CP is secant to the circle at points CD. The lines intersect outside of the circle at point P. What is the length of AP? So I'm asking myself, okay, what do I have? I have 2 secant lines, and I'm going to remember that the total length of the secant line times the exterior part, so the whole line A to P multiplied by the exterior part, so BP, is equal to the whole length of the outside, so CD times just the outside DP. Alright, so what is AP? Well, AP is the total distance, and we can do that by adding this individual segments together. So I know that we have x minus 8, because that's AB, plus 6, that's the other part, times, well, BP is 6. That's going to equal CD. CD is this whole distance. So the first segment of CD is x minus 5. And the second segment of CD is 5. So we're going to add 5. And then DP is 5. Alright, so then we're going to simplify inside the parentheses. So negative 8 plus 6 is a negative 2. And that is being multiplied by 6. That's going to equal minus 5 plus 5 is just 0. So we have x plus 0 times 5. And I know that x plus 0 is just x, because 0 doesn't change the value of anything that it's added or subtracted to. So now on the left-hand side, I have two terms and they need to be multiplied by 6. So I'm going to distribute x times 6 is 6x, and negative 2 times 6 is negative 12. So 6x minus 12, there are no like terms, so I have 6x minus 12 is equal to x times 5 is 5x. All right, so now I'm going to collect all of my x's. So since there's only x's on my right hand side, I'm going to collect all my x's there. So I'm going to subtract 6x. And so we have 6x minus 6x, which is 0, minus 12. That's going to equal 5x minus 6x is a negative 1x. 0 minus 12 is just negative 12 equals negative 1x. Okay, and you might be thinking, well, I'm finished here. Not quite, because this is a negative 1, and in order to make it a positive 1, I have negative 1 being multiplied, so I'm going to divide by a negative 1 and divide by a negative 1. So negative 12 divided by negative 1 is 12. That equals negative 1 divided by negative 1 is 1. So I have now a 1x. All right, we are not finished yet, because it wants to know what the length of AP is. So AP, like we said, was equal to our inside segment, so AB, plus the outside segment, which was BP. And so we have, by substitution, AB was x minus 8, and BP was 6. And now we know that x is 12, so then I can replace that in there. So that's 12 minus 8 plus 6. So 12 minus 8 is going to give us 4, plus 6 is 10. So let's check it. Great job. All right, so there's question 6 for you.